intersecting lines? Okay. I want you to label the top angle as being angle 1 and go clockwise. 2, 3, 4. Because you can see that they're going to ask us to measure these angles. We're going to measure using direct measurement. We're going to put a protractor on it. We're going to actually measure it. Now, when I put a protractor on it, I'm actually going to use a digital one, which you don't have the advantage of doing, do you? Okay. Now, it is important that when you're using a protractor, that you take the time on your protractor to line up the line that's on the bottom and the point that's in the middle with whatever angle you're trying to measure. And I'm going to pull mine across so that you can see the degree measurement. Now, mine came up to, and it's funny, I drew it earlier today, came up with 111 degrees. I still got one. 111 degrees. Okay? I want you to measure angle 1. Don't measure any of the others, just angle 1 for right now. And I'm going to walk by and see how we're doing with measurement. Listen, the goal was that we'd actually measure angle 2, angle 3, and angle 4. But because you guys don't have the ability to do it digitally, you're doing it analog, and you're kind of having to guess when it's not exactly on a line. Here's what I want you to understand. That whatever you got for angle 1, you should get the exact same thing for angle 3. So whatever you put in for angle 1, put in the exact same number for angle 3. Measure it, see if it comes out that way. Really? Okay. Okay. If I take a look at angle 1 and angle 2, where they're at, they make a straight line. Since they make a straight line, they should add up to 180 degrees. So if I measured this at 111, angle 2 should be 69, and angle 4 should be 69. Whatever you did for angle 1 and angle 2 should add up to equal 180. Okay? Again, you're not going to be able to get it exact. Take the time to measure it, look at it, see if it's not close. It should be. But for the sake of argument, we want to make sure that whatever I put in for angle 1 and angle 2, that it gives me exactly what? 180 degrees. By the way, angle 2 and angle 3 would also be what? 180. 3 and 4 would also be what? 180. 4 and 1 would also be what? 180. Because each one of those pairs that you look at, 2 and 3, form a straight line. 3 and 4 form a straight line. 4 and 1 form a straight line, and there's 180 degrees in a line. Okay? So you'll notice 1 and 3 are equal. In other words, they're what? Congruent. 2 and 4 are equal. They're congruent. And all the other ones are going to add up to what? 180 degrees length.
So, I have a question about triangles. So if you just randomly drew a triangle, would it automatically be 180?
Yes, always. Okay? And although that's not with this lesson, I'll come by and show you visually why it has to be later. Okay? Okay. On that next page, flip it over. I want to talk about the definitions. Alex, flip. Somewhere off to the side, take the time to draw two intersecting lines And let's label it like we labeled the one in front. Okay? Off to the side, draw two intersecting lines, and label it like we did what was in front. Vertical angles are opposite angles formed by two intersecting lines. Opposite means across from. So if I'm looking at this picture, angle 1 and angle 3, they're vertical. And vertical angles always are congruent. They have the same measurement. Angle 2 and angle 4 are also vertical. And they would also have the same measurement. Adjacent angles are pairs of angles that share a vertex. Vertex is the point where they meet. And share one side, but don't overlap. In other words, they don't share any part of their inside. Angle 1 is adjacent to or next to angle 2. 1 and 2. They share the point that's in common. They share one side, but they're not overlapping. Angle 2 and angle 3 are adjacent. Angle 3 and angle 4 are adjacent. And angle 4 and angle 1 are adjacent. There's 4 pairs of adjacent angles created by intersecting lines. Now, the next two words you should have seen before, complementary and supplementary. Should have seen them before. And I'm going to tell you, even in high school, the thing that happens is people get confused. They remember something about 90 degrees, and they remember something about 180 degrees, but they don't remember which one is which. Which comes first in the alphabet, complement or supplement? Complementary comes first in the alphabet. 90 comes first on a number line. Two angles that have a sum of 90 degrees are complementary. Supplementary, two angles that add up to 180 degrees. You'll notice that angle 1 and angle 2, two adjacent angles formed by intersecting lines, they're always supplementary because they make a straight line. So every one of these adjacent angles that we listed up here, not only are they adjacent, but they're also what? Supplementary. Okay? Questions about our definitions? Now we're going to start talking about naming angles. When you're naming an angle and it's drawn like this and they haven't put numbers inside, I can't call this angle G. Can anybody tell me why I can't just say angle G? Because there's what? There's more than one angle. In fact, there's many angles where point G is. So when I'm naming an angle, I have to make sure that I name it with 3 letters when it's drawn like this. So to make sure that we're all doing the same thing, they're looking for a pair of supplementary angles. So I'm going to list this angle. Angle FGB. In order to be supplementary to that, and know for sure that it's supplementary, it'd have to make a straight line. There's 2 of them that I could use. I'm going to use this one. And that would be angle BGC. Those 2 angles would have to add up to 180 degrees. Can anybody tell me how big angle BGC is by looking at this picture?
35 degrees.
It is 35 degrees because these two angles are vertical. Name a pair of vertical angles. Well, I'm going to use the two that we just used. FGE and angle BGC.
Number 5, it says name a pair of supplementary angles. Okay, I'll say complement. Okay.
Supplementary means they add up to what?
I'm good.
180.
I'm good.
Okay? By the way, is that the only pair I could have listed? No, there's lots of pairs. I just listed a pair so that we were all doing it the same way. Name a pair of adjacent angles. Well, there's lots of things again that I could do. I'm going to use FGE like I did here. Adjacent to FGE, side by side to it, if this is FGE, right next to it, I could use FGA. Could anybody tell me how to find this angle measurement? Does anybody know how I might be able to find this one, FGA? I could, but this may not be drawn to scale. But I can find it indirectly without actually measuring it and know exactly what it is. Alexis. I'm sorry? You are right. Why can I do 90 minus 35?
Because the first two angles connected, it makes it work 90 degrees.
Right. If this one's 90 degrees, then over here also had to be what? 90 degrees. 90 minus 35 is 55 degrees. So this angle would be 55. Name a pair of complementary angles. Since these two angles added up to 90 degrees, couldn't I use the same two angles? Yes. Angle FGE and angle FGA. And in the last problem, it says find the measure of angle CGD. So they're looking for this angle down here. How could I find the measure of this angle? Anybody? Brian?
Since along with BGC, those two equal 90, so take 90 minus 35 again.
I could do that. That would work. There's an easier way in this case. Look at the angle that's across from it. Vertical angles are always the same. If angle FGA is 55, then this angle is also how big? 55 degrees. But what you said would have worked, Brian. Okay, questions? Everybody okay so far? Okay. I think you had to flip page. Let's look at number 10. What can you tell me about the two angles that they have here? Brian? Okay, both of them added together are going to be 180. Which means they're what? What's the word? They're supplementary. They're adjacent and they're supplementary. If both of them added together equal 180, I can write an equation. 3x plus 54 equals 180 degrees. What would I do to solve this equation? I'd subtract 54 from both sides. I now have this, 3x equals 126. What would I do now?
3 divided by 126.
I'd take 126 divided by 3. X would be equal to 42. Is that what they asked me to find?
No.
What did they ask me to find?
Measure.
The measure of angle JML. What would I have to do right here? I'd have to put that back in, since angle JML was equal to 3x. I have to take 3 times 42, which is 126. Everybody with me? Okay. Let's take a look at number 11. Corey says that to find JML above, you can stop when you get to this step. 3x equals 126. It says explain why this works. Why does it work? Why could I stop right there when I get 3x equals 126? Hugh?
Because you only need to find the measure of it,
The measure of what?
of JML.
And what is JML?
3 times
3, it's 3x, right? So once I get to 3x, do I need to solve for x? No, 3x was 126, so I had no reason to go any further. Okay? And the reason we can stop is because JML was equal to what? 3x. Questions? That's your assignment. No.